Hello everyone, thanks for coming this late. I am glad to announce that we have our first contribution using Gaussian Splatting for Scenarios project. Why this is so important? But actually we prove we can recreate environment in 3D without expensive compute using Gaussian Splatting, and also it's possible to simulate drones for footage in this 3D scenario for smart footages, Reconstruction, and how we can use several applications like, for example, Unity, Blender, and this is benefits because it reduces the iterations with drones in real life. It means that we don't need a quite long data set using these drones to take pictures, and also we can make contribution to try to apply data augmentation for machine learning models, and also it could be useful for data preprocessing. And of course, it's important that we can prove that it's possible to improve the tracking algorithms, like for example YOLO or VEXAC, etc. So let's go to the results. This is like a Bosch close to my university, and we trained this footage about 3,000 iterations. The video it's more or less 1 minute approx, and we could extract 167 frames. So we have here some video examples. For example, we have the ground truth. As you can see, this is the tracking without any apply preprocessing. This segmentation works perfectly, but for our point of view, we don't have any interest in the bush in the backside or from the main bush where we have interest. So we have just interest in the main foreground here. So it could cause noise and actually some difficulties at the moment to try to apply this for machine learning training or anything. But after the Gaussian application, we could represent this bush in a 3D environment. And what is the result? Look at this. Actually, we have here the region of interest. It means we have just the object that we want to be focused. And also we have here the leaf extraction for deeper analysis. That in this case is the analysis, the disease detection or disease prediction. Okay. So there is a case, and also here we record a plant in the office that it shows also another problem. As you can see, there are some segmentation in some furnitures and also in some walls that these are false positive. Actually, it's not the plant itself. So this is a problem. So how we can solve this? Actually, we can apply Gaussian splatting. I would like to make a small practical demonstration that how we can use Blender, specifically the add-on for Gaussian splatting analysis, and let's see how it works. For example, here I have my Blender Studio, so I can import the PLY application. Let's try to find this. It's today, yeah, it's this one. Okay, perfectly. We have the advantage that at the moment to load a Gaussian splatting item, this is not heavy, so we can interact with this very easy without any problem. But at the moment to try to renderize this is another story. It's more complex and it's more heavy for talking about computation resources. Okay, so here we can apply some comments in Blender Studio, like for example, we can just look the material preview, and also if we select the object itself, so we choose like a splatting object, and we choose the option to to have a view of as point cloud. So here we have the scenario, but actually we have a lot of external factors that we are not interested. For example, we have here some walls, some furniture that actually it makes noise, so it doesn't make sense to have these cloud points. Because at the moment to try to make analysis for 3D, so here we can make some interactions with the goal to try to generate animations and at the same point to generate new data of the regions of interest, and there are several ways that how we can do that. So for example here I have a third-person view that I can manipulate the camera, but I would like to say the drone, that in several positions, spatial positions, and in this way we can, how to say, personalize the coordinate flight to the camera to achieve flight drone simulations. So for example here, if I choose the camera and if I go to the item option in Blender, I can check how it's the point of view of the camera. So here I have like a good angle, so I can decide to add these coordinates. And here I have my first keyframe. So if I am not happy with this position, doesn't matter, I can't again interact with the 3D scenario here, and I can make another footage here, for example, from the top or even more close. So yeah, this is another angle of the camera, and I can decide if I want to add the coordinates. So how this animation look? Let's see. Yeah, this is just an example. I actually have another results, better ones, but this is just to try to explain the practical part. So let's see. This is the point of view of the camera. Okay, so it's okay. But how it's from the third-person view? So we can see here that it is easily a drone flight simulation. And what results we have until now? Well, do you remember that for the puzzle case we have a lot of noise in the background, some false positive, and now after the Gaussian Splatting interaction we could achieve just to get the region of interest of the plane. They are not background, they are not false positive, we have just deeper details of the leaf itself. So this is important because the Gaussian Splatting, it was thank you to the Gaussian Splatting application, and the idea here is to apply the same principle for the agricultural fields. So for example, what we have here, where we have the contribution for possible drone flight simulation, and the following step will be that we can, after of the data collection of the agricultural fields, we can recreate this in 3D, and we can apply drone flight simulation to apply smart footages and smart navigation into the agriculture. So actually, after 1 or 2 iterations, we can apply a smart footage to try to avoid the data that is not necessary. So that's it. Thank you. Yeah, actually we can start from there, and we can find more use cases after of the 3D interaction. That, for example, here if we go, I don't know, to Slovakia to have this data collection from the drones, we can, how to say, simulate these flights to, at the moment, to go to for a second iteration to try to have better data. And also we can, I don't know, but I mean,
yeah, that's fine.
but we we can talk with Eman because it's possible to, how to say, to apply unsupervised model learning for this round.